All right, this is Professor Cooper. I'm going to do a little color theory and color talk when it comes to our visualizations because this is a good time for you relative to your labs coming up. Um, so I'm going to kind of hop back and forth between these slides and R. Um, what we're really doing with visualization is we are starting with unlimited, multi-dimensional information about the real world, and then we are simplifying it and reducing it to some core components. And then for data visualization, what we're doing is we are further reducing it to line, shape, size, physical features on a plot that represent something that's way more complex than just line, shape, size, color, etc. Right? Um, we're using data that have variation and then mapping those onto these simpler features that we can understand with our eyes to tell a story about what's going on in the world that's very complex, right? Um, we reduce it to the appropriate, in our case, aesthetics, but then we also reduce it into color, shape, maybe even texture if we're doing it very well. Um, we're emphasizing relationships and appropriate plots. The best visualization is both scientific and artistic. All right. You want to make the best of a subset of appropriate visualizations, and there are right alternatives. There's never one true right answer necessarily, but there is a subset of right answers and a subset of wrong answers when it comes to what choices do you make for a visualization. Great graphics are essentially, they're very intuitive, they're clean. Nobody wants to see how you labeled your data in your data set. Those things need to be cleaned up. They need to be informative. There should be some new story being told by the visualization that you couldn't tell just with a table of numbers or potentially the paper itself if you're writing a paper. The visualization needs to be accurate. You shouldn't be misleading the reader, misleading the viewer of the information that's being relayed. And it should be reductive in the sense of what I was saying before, that you are reducing an incredibly complex world into a few elements on a plot, right? Your eyes like pictures. They like pictures more than they like tables of numbers. Everybody glosses over when they see a table of numbers, but people can understand and potentially get behind visualizations. In the COVID-19 pandemic universe that we're now in, um, we are relying very heavily on visualizations. You've seen logarithmic maps of cases and deaths, or raw linear of cases and deaths on a daily, weekly, monthly basis. Or you might even seen a map like the Johns Hopkins COVID-19 dashboard map. These things are dominating the headlines right now because they're really important for us to be able to understand what's going on. Because, God forbid, you try to actually read the table of data, your head would spin and you wouldn't be able to make heads or tails of it. You wouldn't be able to understand it anyway. So these are increasingly important skill sets for you right now, is all I'm saying there. There's a classic data set, and it exists natively in R to demonstrate this. It's called the Anscombe quartet. Four sets of X's and Y's that if you were to run a linear regression on them, you would get the same effects of the X's on the Y's. And yet, if you were to look at them in a visualization, you would see that the patterns are actually very different, and that there would be different prescriptions for sort of further analysis based on actually going and seeing the visualization. Some principles of good data visualization. It's more often than not a really good idea not to overcomplicate a visualization, to quote unquote spend your ink, your digital ink, you might say, on data itself, the variation in the data, and that's it. And Edward Tufte talks about, um, he's a famous visualization professor at Yale. If a part can be erased without losing any graphical information, you should consider erasing it. There are certainly exceptions to this rule, but as a general rule, this is a really good idea. He calls extraneous stuff in plots chart junk, and we're going to talk about that a lot as well. Want to flash here for you the first known line plot. Um, it's from the late 18th century by a person named William Playfair. You can see it's pretty basic, but it's actually really cool. There's actually some interesting things going on. There's some good labeling. They're basic line plots. Some color is involved, which is nice. Um, this these extra lines, the grid lines that change right here, emphasizing the change in variation from the period of 1700 to 1770, and then 1774 is actually kind of interesting. Um, you're going to actually have a chance to recreate this for some bonus points.